Greetings, fellow GGs. Yearning for a nice cool drink after a long day of work? Are you tired of drinking perfectly cold water right out of the fridge? Do you have nothing better to do other than to invest your hard-earned money on some questionable product created by a couple of sad and sleep-deprived first years? Well, whether or not all of that applies to you, CHM 123 presents to you the newly innovated, never seen before 5K GG drink. It's a drink that cools while you think. Now, this is no ordinary sports drink. Oh no, it's not. In fact, it's not a sports drink at all. This is a sweet, cool, self-cooling drink that is capable of cooling down 100 milliliters of water. Remember, it's water. It cools it down by 5 degrees Celsius in less than 5 minutes. All you have to do is just press a button on the bottom of the can and shake it. So what's the science behind this amazing product? Well, for one, this is all thanks to our best friend, chemistry.
Hi, I'm chemistry, their favorite subject. I'm totally not the reason for their eternal pain and sleep deprivation. Like, how could they have created this incredible, life-changing, super significant product without me? Anyway, moving on, let's go deeper into the theory behind the 5K GG drink.
For one, it all starts with enthalpy. So what is enthalpy? Simply put, enthalpy is the measure of energy in a thermodynamic system. It's the sum of the internal energy and the product of pressure and volume.
Now, enthalpy change is the thermal change that accompanies a chemical reaction at a constant volume or constant pressure. It indicates the amount of heat absorbed or released during the reaction. It is expressed by delta H. For this experiment, we focused on 3 types of enthalpy changes. The enthalpy of dissolution, which is the enthalpy change when 1 mole of salt is dissolved in a solvent. The enthalpy of hydration, the enthalpy change when 1 mole of gaseous ions dissolve in water to form a solution. And the enthalpy of lattice dissociation, the energy released to create gaseous ions from 1 mole of salt. We found that the enthalpy of dissolution is the sum of the enthalpy of hydration and lattice dissociation.
2 of the 3 changes in enthalpy were exothermic, meaning energy was released. The lattice enthalpy of dissociation and the enthalpy of hydration. The overall enthalpy of dissolution was exothermic, meaning overall energy was absorbed into system during the reaction. Something to point out here is Hess law. Under constant pressure or constant volume conditions, whether it is complete in one step or several steps, the heat of reaction is the same. In other words, the heat of reaction of a chemical reaction is only related to the initial state and the final state of the reaction system, and is independent of the route of the reaction.
So, my fellow first-year friends, why did you choose the salt ammonium chloride over ammonium nitrate?
Well, it's simply because we didn't want to risk our lives dying in an explosion, creating this incredibly life-changing product.
Yeah, you see, ammonium nitrate is actually known as a deadly explosive agent, and we didn't want to get sued or anything if someone were to get injured as a result of using our product.
On the other hand, it can be used as an additive to some of the foods we eat, like licorice. Its health effects on humans is milder than that of what ammonium nitrate can do, and it's not known as a deadly explosive oxidizing agent.
Ammonium chloride is also cheaper than ammonium nitrate. $62.40 per 500 grams, Canadian I might add, for ammonium chloride, and $64.62 500 grams of ammonium nitrate. So in terms of safety and cost-wise, ammonium chloride just seemed like a better option overall.
So what was our procedure for testing this product? In simple terms, we took a calorimeter, an empty aluminum can, and filled the both of them with 100 milliliters of water. We then added a secret amount of ammonium chloride into the 100 milliliters of water in the calorimeter and mixed the two. Afterward, we placed the aluminum can into the calorimeter salt solution and we placed a lid on top to ensure it was a closed system. Then we stuck a thermometer inside. After 5 minutes, we checked to see if the drink cooled down by 5 degrees Celsius. We applied a very similar method or procedure to our end product.
Hey, why did you keep the amount of ammonium chloride added to the water a secret? I want to know how much you put in there. Also, what were your results like? Any errors and stuff? Come on, spill it.
Well, you can consider all that as part of our secret formula that we don't want to share to the public. So if you want to know the details of the procedure and how much mass we used or any other more detailed information for that matter, just refer to our report.
Yeah, this is getting too long. Let's end it here. The animator's animations are getting crappier by the second.
Oh no, where'd my feet go?
The 5K GG drink. The drink that cools while you think. Get one now while the non-existent supplies last.